Guys, 1 second. Harika, are you there with me? Okay. Yep. Hadoop is required because we found some limitations with the existing system. It's called traditional approach, where that has been designed a few decades before. At that time, the amount was very less. I mean, amount of data was very less. So due to that, that approach works very well. Now the data increased drastically. I mean, this is a huge amount of the data is there in the worldwide now. So to, now with this data, our system is failing to process. Because of the data is grown, we started seeing some limitations with the traditional approach. Those limitations are like to implement the cost is one of the limitation, and the time is one of the limitation because it's taking so much of time. It doesn't mean that your traditional approach will not process the data, store the data. It can store the data, it can process the data, but it will take so much of time. It will take so much of time. So we found these limitations. We don't, it is taking so much of time because it does not have a data locality, it does not have a auto fault tolerant, it does not have a parallel processing, it does not have no what to say automatic backup, automatic replication. These are the limitation we saw with the traditional approach. These are the limitations we saw with the traditional approach. That's why we started looking for a better approach who can improve the time, we can perform the improve the performance, and where we can get the results very quickly. Where we can get the results very quickly. Who caused, right? That is Hadoop, right? So who caused the problem in the traditional approach? Before it was working very well. Now who is the no, because of what we started seeing the some limitations, Harika?
Huge data.
Because of huge data. Because of the huge data, we started looking at the some limitations. What is that huge data we can call? Can we say it's a big data? Can we say it's a big
Yes.
data? What is big data? What is a big data? What is big data? What is a big data? Anyone? Anisha, go ahead. Huge amount of data. Very good.
Yeah, big data, like the very huge amount of data which cannot be solved using traditional approaches.
Very good. It's a huge amount of the data. Huge amount of data. How much huge? How much huge? How much huge? Is there any limitation? Like saying that 1 terabyte, 2 terabyte, 3 terabytes, or 1 petabytes? Is there something like that?
No limitation.
No limitation. Very good. So if you say no limitation, can I say 100 MB is a big data? Can I say 100 MB is a big data? Sachin?
For some databases, it is a big data.
Sachin, can I say 100 MB is a big data? Yes. So how can I say 100 MB is a big data? How can I say 100 MB is a big data? Because there are some systems which are not able to process even 100 MB of data, like your Gmail email application. Not only Gmail, any email application. You cannot send 100 MB as an attachment through an email, right? For that application, for that specific application, the 100 MB is a big data. So there is no limit, there is no specific measurement saying that this much amount of the data is a big data or this much amount is not a big data, right? Whatever the data we are not able to process or store and manage or process using an existing system, that data is called big data. That data is called big data. So is, let's assume that is I have some system which is not able to process 1 GB of data, not able to process in sense. So I want the report in 5 seconds, guys. I want the report in 5 seconds. If I'm not getting the report in 5 seconds, I want the report in 5 seconds. If I'm not getting the report in 5 seconds, then my current system is failing to process data or manage data. Correct? It doesn't mean that my system is completely crashing, or it doesn't mean that my system is completely dying without unable to handle the data. My requirement is it is not able to achieve my target or my benchmark. I want the report in 5 seconds. If my machine is taking 10 seconds, 20 seconds, I mean my current system is taking 10 seconds, 20 seconds, it means that my system, my current system is not able to process to achieve 5 seconds of time. Understand? So whatever the data the current system failed to process to produce a report in 5 seconds, that data we can call as a big data. Clear, guys? What is a big data? What is a big data? The data which is not able to process or store or process using a traditional approach, or using a traditional approach means existing system only. Okay, using traditional approach, that data we can call as a big data. Clear on this, everyone? Then I'll move to next topic. If you guys say yes, then I'll move. Is this clear, guys?
Yes.
Okay, good. Any questions? Sachin, Kishore, Hamid, any questions?
No, sir. Clear, sir.
Okay, okay. Let's look at let's look at classifications of big data. Not only big data, any data, guys. It's a classification of data. It's not a classification of big data. It's a classification of data. What are they? Any idea? The data has been classified into three categories. What are they? Any idea, guys? Any idea?
Structured data, unstructured, semi-structured.
Structure,
Unstructured, semi-structured.
unstructured, semi-structured. Few guys will say only two categories, which is a structure and unstructured. Few guys says three categories like structure, unstructured, and semi-structure. We will see all three categories. We will see all three categories. Okay. What is the structure? What is the structure? Kishore, Sachin, Anisha. What is the structure? What is the structure data?
Data that comes in a fixed format.
The
Uh,
data which can be in the format of rows and columns, which are
mhm,
arranged like in the form of CSV files.
mhm. Sachin, you were telling something?
I said data that always comes in a fixed format or some format.
Okay. Yeah. So when you look at the data, the whole data follows a specific pattern, a specific schema. Always, as Sachin said, the data always comes with a specific pattern. The data always comes with a specific single delimiter. So when I look at the whole data, when I look at all the sources of that data, it follows a specific single delimiter. It will not be having a multiple delimiters. Even if it has a multiple delimiter, that is and always comes with that delimiter only. Specific schema. Let's take an example as our database tables. How your database tables looks? How your tables looks? How the data will be divided into database? Columns. Columns. Not the rows. Rows is a number of how much of data you have. The data is divided into columns. Columns, right? Suppose I want to get the first column, second I want to get the second column, third column, like that. So it's a column. So data is divided into column. You take any table. You take any table from any database. The data is divided into columns. Can I say this type of data is structure? Right? So one example is for structured data is tables. Any other example? Excel sheets, your XLS files, your XLS files, your CSV files. What is a CSV file, guys? What is a CSV file, Harika? Do you heard about the CSV file before?
No, sir.
Okay. CSV file means comma separated values. CSV means comma separated values. Comma separated values. Comma separated values means the whole data, when you look at the data, the data is separated with a comma. The whole data is separated with a comma. Like if you have some data like first name, comma, last name, comma, phone number, comma, address, comma, email, comma, and so on. The whole data, when you look at the data, first name is something, last name is something, phone number is something, like this. The whole data is divided by, separated by comma. There are so many
Are you
CSV
by any
files.
chance sharing your screen?
Am I not sharing my screen? Oh,
I'm
sorry
not able
guys.
to view. No problem.
Are you guys able to see my screen now?
Yes.
Oh, okay. So when you look at the any of the file, so like a first name comma, last name comma, phone number comma, address comma, email. So the whole data, when you look at the whole data, the data is divided by single delimiter. The delimiter is comma. The delimiter is comma. So this is also specific structure is there, which is it is following the, if you take any CSV file, it has the same structure, which is delimited by comma. So this type of data also you can say structure data. Like not only CSV file, you can say tab separated value. Same. Instead of comma, it will be tab value, tab separated value. Any data which follows a specific delimiter. Or else you can also write your own, or else you can also write your own or else you can also write your own data. Something looks like first name, pound, last name, pound or hash, whatever you call, phone, pound, email, pound. Like your data comes like first name is, let's take a Vida, last name take SNGIRI Singiri, take phone number, some number 9986 some blah blah blah. You take email, viraravi.singiri dot dot dot. So if you look at my data, the whole data is going with a specific delimiter. This type of data also we can call as a structured data. Any doubts, guys? Are you guys clear about the structured data? Anisha, Anisha and Harika, because these are the guys who are freshers. I mean, who are new to this. I just want to ask them. I mean, I'll be asking more questions from them. So, Anisha, Harika, understood?
Mm,
Hamid,
yes,
Sachin,
no doubts.
yeah. So now, what is unstructured data? What is unstructured data? Sachin, any idea? Unstructured data? Unstructured data?
I think it doesn't follow any specific formatting rules.
Very good. Okay.
Like system coming from different, information coming from different systems has its own different data, different
Okay.
formattings.
Okay. Any examples?
Uh, Information coming from logging system would be different than Windows system, than Linux system, than security system.
So you were telling the log file.
Log or any information, basically it's information, right? It doesn't follow any specific guideline or formatting rule,
Okay.
like JSON
I just want to see some. Okay. JSON. Okay. Okay.
and some security logs that come. They have different
Or logs. System logs or security
logging
logs.
mechanisms like that.
Logs. Okay.
Yeah,
Anything
like
else?
Cisco log. Any data that doesn't follow any specific formatting rule, right?
Can I say text?
Absolutely.
Can I say email?
Mm-hmm.
Emails? Can I say XML files? These are all falls under unstructured when you have only two categories. When you have only two categories, when you have only two categories, this all falls under unstructured. But here we have categorized three categories. There are specific files which falls under unstructured. Those are like your images, audio, and video. Are they follow any structure? Are they follow any structure? No. So the specific examples are the exact examples for the unstructured data is images, audio, and video. And I'm not denying such an answer, but because when they have only two categories like a structure and unstructured, yes, the log file, text file, emails, XML, or JSON, these all falls under unstructured. But when we categorize three categories, it means unstructured is complete. It's completely unstructured. It doesn't have any structure. But when I look at this log file, or when I look at this JSON file, or when I look at the text file or XML file, I do find a specific structure which all follows. A specific structure which all follows. Let's take
Agreed.
let's take log file. Let's take a log file. How generally all the logs will look like. If it's a web log, it is a system log. There are different. But let's take an example of a web log. I'll be having IP address and some tab space or some delimiter, and I'll be having a timestamp when it has generated, and I'll be having a date. A timestamp itself will be contain the date. Some people will separate the date and some the OS, which operating system it has been used, which browser it has been used, and what is the type of a log, whether it's a warning log, it's error log, it's a debug log, what type of the log, and so on. It will be like this. But when I look at this, I have a structure. I have a structure, some value here, some value here, some value here, and some value here, some value here, and some value here. I have a structure here. How can I say it is a either unstructured or a semi-structure? It has a proper structure. If you take any log, it has a proper structure. How can I say it is unstructured or semi-structure? Any idea? Any idea? How can I
So
say
the
it is?
format, say, if you're looking at the log, right? If it is security log, it'll have a different structure. If it is a Windows application log, it'll have a different structure. So all different information in different structures or formats is going into the same system that will be saved.
But
Like you said,
yeah, but the
yeah,
delimiter is same, right? But when I look at the
not
data,
necessarily.
my question is, I mean, the when we see the data, yes, it should
Yeah, it is in
follow.
some structure. Agreed.
It is in structure, correct? But
Some structure, yes.
this is a successful log, correct?
Huh?
It is a successful log. Successful log means I have done my operation successfully. Whatever the operation you have done successfully, the logs come successful log. But something went wrong. So like some field is missing, it is thrown null pointer exception, or it thrown some some type of exception, class some different kind of exception, not taken to Java exceptions, different exceptions. So that time what will happen? The structure completely change, not exactly look as structure, right? So there was your log may success or your log may fail. I mean your operation may success or may fail based on the successful log looks a proper structure. When the log is fail, when operation is fail, it will generate the failure log information. So that's why it will not be having the same structure when you look at the log file.
Right.
So that's why the log falls under semi-structure
Semi.
category.
Mm-hmm.
Log falls under semi-structure. Coming to text. So some people says text file is unstructured. Text file is unstructured. Yes, correct. They are also right when they categorize the text file as, I mean, when they categorize the whole data into two categories like structured and semi-structured, structured and unstructured. Yes, text will falls under unstructured. But when we categorize three categories, the text will falls under semi-structured. Why? Else, when you take a two text files, if you take any text file, so one text file may different looks different, another text file may looks different. Let me open some simple example. Look at here. This is some code. Code is nothing but text. This is some code. This is some file. This is some database related one. This is some kind of log it is. This is some kind of log it is. So when I look at this text and this text is same. This text and this text is same. No, but one text may have a subheadings, bullet points, something. But when I look at the two text files, I cannot make out the proper structure. But when I go on level down, when I look at the line by line, when I look at the line by line, yes, I may find some structure because each text file or each whatever it is generating, the files will comes in the lines, right? Each line is a collection of words. Each line is a collection of words. Each two words are separated with a single space. Agree? Agree? Two in the line, two words are separated with a single space. So I have a scope where I can identify, yes, I can delimit this, I can process this data by using a space. That's why your text files falls under semi-structure. So when you look at the line by line in the two text files, if you take one CV, you take CV1 and you take some other payslip or whatever it is, bank statement. When you look at this, no, it will not be similar. Not bank statement. Bank statement comes in the table format. Let's take some other your notes or Hadoop notes. So when you look at these two, not similar because your CV will have some different structures, headings, subheadings, and all these things will have. Your notebooks you may not have that is a plain text. But when look at the line in the each file, it's a collection of words. The two words are separated with a single space. So I have a scope where I can go ahead and process it using the space. I can delimit the data using a space. That's why your text files also comes under semi-structure. Agree? Agree? Yeah.
Agreed.
Let's take emails. Emails are ideally it's also text files like where you can see you'll be having a to address, subject, and from address, and you'll be having a signature and all. But even though in between whatever the information you get, it comes in the structure only. Okay, let's take another one, the most important things, and XML and JSON. So let's talk about XML. XML, how it looks. The XML files looks like there will be parent tag and there will be close parent tag or close tag. So again there will be pair tag and there will be close tag. When I look at other XML file, it comes like a parent with some attributes. It may come with a child tag. The child has again a subchild. Now subchild is closed, child close, then parent close. Little both are different. When I'm trying to process my data using parent tag, I may miss this. How to process these things. So they have a structure when I look at the two XML files, but the both are not similar. Both are not similar. So your XML also comes under semi-structure. XML also comes under semi-structure. And let's take over the JSON files. JSON files are, so let me open, I think I have some JSON files with me. I want to make everyone clear about the JSON files because most of the kids may not see in the JSON file. It's a joins, not a JSON. Is it? Let me open some JSON file. I think I do have some JSON file somewhere. It will be there. Or else I can get some JSON file. Let me get through online some JSON file because most of the guys might not see in the JSON files. Actually, the JSON files looks like a key value pair, and it'll start with the curly braces, and it'll be having a. It looks like a key value pairs. Let me open JSON formatter or validator. So it may give you some example for you. So it asks me to type here, paste it somewhere. I thought it'll show some example. Just give me a minute, guys. I'll open the JSON example file. Yep. So this is how the JSON file looks. This is how the JSON file looks. Do you guys say it's a structure? Do you guys say structure? But I do see here there is something key and specific value. There is some key and value, and you see again a key value, again a key value, again a key value, again a key value. Everything is in the JSON file is a key value pair, but it's not always follows the same structure. One row has a one key value pair, only one key and value, and other row may have a value may contain again a key value pair, right? You can easily, by looking at this data itself, you can easily make out it's not a structure. Even it's not unstructured. It has some structure internally. It has some structure internally. So that's why we'll bring your JSON file into, you'll bring JSON file into, we'll bring JSON file into semi-structured category. Are you guys clear about the classification of data? Guys, are you guys clear about the classification of the data? Then I'll move to next.
Yep.
Harika and
Yes.
Anisha, Amit, especially for you guys, this is because Sachin, I think he has a good experience, and Kishore also has a good experience. They know it, how it looks. So these basics are mainly for the guys who are not from the, good background. Okay. So if you guys have any doubt, even the small doubt, please ask me. I love to hear the doubts from you guys, because when you ask the doubts, it means that you are asking me. You are concentrating. You're trying to understand something new. Okay. The next topic is characteristics of data. Something went wrong here. Characteristics of data. The characteristics are like you guys might have heard before, here and there in the blogs or books, saying the 3V. There are 3Vs. Actually, these are not 3V, these are 6Vs. I'll explain what is the 6Vs. One is volume. One is volume. It represents how much amount of the data we are dealing with. How much amount of the data, what is the size of the data, what is the volume of the data we are dealing with. And other one is velocity. How fast the data is generated, how fast the data is getting generated. So if we take in 80s and 90s, to generate to generate 1 GB of data, they might have taken a good amount of time. But nowadays, the Facebook itself is giving 100 TB data per day. The Twitter is giving same amount of the data. Your WhatsApp, your mobiles, so how many people are using mobiles? There are so many CDRs are coming. There are so many people are getting huge amount of the data, right? YouTube, every 1 hour, every second, 40 fresh hourly, I mean, 1 hour videos are 1 hour length videos are uploading every second. So 1 hour means hardly it's 150 MB. And again, it's a quality. So HD quality, different kind of quality, the size will be vary. So that much amount of the data is coming to all, right? How fast that is getting generated, that's representing by velocity. That's representing by velocity. And other V is variety. We have seen different kind of data already: structured, unstructured, semi-structured, right? Different kind of varieties of data. So it's not always everyone is giving the same type of data. One different systems are different, designs are different, systems are different, sources are giving different type of data, right? And the next V is variability. Variability says that currently I am using structured data because my source, my design, my application works with the structured data. And tomorrow all of a sudden I am also connected to some other source where I'm getting the unstructured or semi-structured type of data. My system should not say, no, I cannot handle this. Your system should be capable enough to handle that type of data also. That's a variable. It's a keep changing. The data may keep change. So because your data is changing, you should not always, whenever your data is changing, if you go and start changing everything from the scratch again, it is a, it's involved, so cost or so much of time is involved on it, right? Whatever the approach you are following, it should be ready to accept any type of data. That's a variability. So today I'm handling with tables. Tomorrow I may get with the data as the logs, or tomorrow next minute I may get the data in the form of audio video files. My setup, my environment should be ready to accept it, right? That's a variability. Variability means keep changing. So today I'm emitting, so let's take a source point of view. So today I'm giving structured data of data. Tomorrow I may give log, different kind of data. So it may change. That's a variability. Next one is veracity. Veracity. How accurate the data is. How accurate the data is. how good the data is, how trustworthy the data is, right? So that's also one of the character of the data. That's also one of the character of a data. The final one, and the most important one, is value. Value, the most important one out of all these five or six. The value, why we are attending sessions, why you're spending a valuable time. The two who are there in US, they're spending a valuable time on Sunday evening. And why we are waking up in this much early, and why you're attending the session, right? To learn Hadoop. If you learn Hadoop, it will add an advantage, or it will add your professional career. It will add you know for your career. If you have a good career, you will get a good value or good salaries, whatever it is, right? So the value is most important. Why the most of the people are doing analytics? They get the analytics based on those, the report, they will take an action. If you have processed the huge amount of the data, you didn't get any information from out of it, you didn't get any information out of it, so no use. So the value represents whatever the data I have processed, it's giving you a value to improve your business, or whatever it is, improve business, improve your career, whatever it is. That's the most important V is in out of the six is a value. Understand guys, characteristics of the data. Understand the characteristics of the data, right? Any doubts? Right? This is about a data. This is about a data. So data is big data. I can say data is a big data, the different characteristics and different types of data, and uh, different type of data or different characteristics of the data. We should be able to process that. We should be able to get a value out of it by using Hadoop. So how Hadoop solves the problem which we saw using a traditional approach? How Hadoop solves the problem or limitations which we have seen with the traditional approach? What are the limitations with the traditional approach, guys? What are the limitations? Hamid, are you there? Hamid, Tanisha, Kishore, are you guys able to hear me?
Yes, sir.
Yes.
Anisha, you? I think Sachin has some problem. Sachin asking, is other also facing the same problem? I think he's not able to. So what are the limitations we have seen in the last session? Could you please tell me? Anyone?
Cost, time, no data localization, no parallel processing, no auto replication, no
Oh,
fault tolerance.
very good. One by one, please. Seems that you have by heard it. Cost,
Yeah, tell.
time, no data
Yeah,
localization.
one of the two main limitations is like the time and the costs more important.
Yeah. The fourth one, no parallel process, no auto fault tolerant, no replication, automatic replication. Right? These are the limitations we have seen with the traditional approach. How to solve them? How to solve them? What is the solution? What is the solution?
Hadoop.
What is Hadoop? What is Hadoop? Anisha, Harika, Kishore, Sachin, what is Hadoop?
Hadoop is open source Java-based framework that
Hmm.
can store and process big data.
Very good. Hadoop is an open source Java based framework which will store a huge amount of the data, which will process the huge amount of the data efficiently. It doesn't mean that our existing system cannot store and process. They can also store and process, but it will take so much of time. But I want the report in 5 seconds, 10 seconds. But if your time, if your mission is, if your process or approach is taking half an hour, 30 minutes of, 30 minutes or 1 hour of time, no one interested in that approach, right? So how it is solving? How we are achieving the time, less time? How we are processing the data that fast? Because Hadoop come up with the two components. What are they? Hadoop come up with the two components. One is HDFS. Other one is map reduce. Map and reduce. Map and reduce. What is the HDFS, guys? We have seen last two classes. We have discussed about the HDFS only. What is the HDFS? It is a Hadoop distributed file system. What it is? It is a Hadoop Hadoop distributed file system. It is a file system. What it is? It is a file system. What type of file system? It is a distributed file system. It is a distributed file system. Try to understand what is the distributed file system. What is the distributed file system, guys? What is the DFS? What is the distributed file system? What is the distributed file system? Anyone? Sachin, are you able to hear us?
Yes,
Okay. Yep. Yep.
I opened a new session.
Okay. Okay. So Kishore, Harika, Hamid, Anisha, what is the DFS? Do we have any DFS in the market now? Already? Is there any DFS available in the market already?
Yes.
Then why we need Hadoop? First try to understand what is the distributed file system. What is a distributed file system?
A distributed file system which runs on a single cluster and single machine.
Hmm.
There is no data replication.
Okay. Okay.
If
Anyone else?
if the DFS one machine goes down, then we cannot retrieve the data.
Okay. So let's try to understand. Distributed file system means we're distributing the data across the multiple machines. We're distributing the data across the multiple machines, but each machine stores a specific type of data. Each machine stores a specific type of the data. So your DFS follows client server, client server architecture. How it looks? Look at here. You'll be having a machine, one machine here. You'll be having one machine here. You'll be having one more machine. You'll be having multiple machines underneath. And you'll be having, when you create a distributed file system through a network, oh, what will happen? When you create a distributed file system layer, it will create one virtual layer on top of these machines. All these machines are connected to this layer, and there will be a client who will be accessing this layer. This is, let's assume that employee, let's assume that student, let's assume that projects, this assumes that software. So all employee related data will go into employee machine, student related data will go into student, the projects related will go into projects, and software related data will go into software. Software related data will go into software. And client, what are the data he has an access, he can go ahead and access the data. So but for the client, you have a underneath the four systems, you have a four systems underneath, but client knows only one path. Client assumes that only one computer, because all are connected and all are looking like a single path, all are looking like a single hard disk. When they started sharing their data to this layer, when these guys started sharing this data to here, these guys started this layer, everyone started sharing the data to this layer. For the client, it looks like a single hard disk. For the client, it looks like a single hard disk. That's how in our companies we'll be having a shared drive. You can share data, your colleague can share data, or someone can share data. So whoever shares the data, it will go to a specific path. It will go a specific path. Let's assume that the specific path is, let's assume that the specific path is slash share. Everyone is sharing the data here. Under this, they may create data. Under that, they may create a folder. But this is a single path. This is a single path. One second, guys. I'm just getting a call. So when you're sharing multiple data from multiple computers, but the client, it knows only a single path, or he looks like a single hard disk. That's the DFS. Okay. So for the client, he knows. Okay. So he'll never come to know that how many systems are there underneath. He'll come to know only one. He treat it as a single entry for him, and he'll treat it as a single hard disk. Right? This is called a distributed file system. This is called distributed file system. Now, already I have a distributed file system in the market. Why should I go with the Hadoop distributed file system? Why should I go with the distributed file system? Let's try to understand what is the limitations are there with the distributed file system. Then we'll try to see how Hadoop distributed file system works. Right? With the very first one. So is there any mechanism here? As soon as I load the data into this distributed file system from here, from the software or from here, is there any mechanism I can copy into 3 different places or 4 different places? This environment everyone knows. Most of the guys in colleges also, they have a shared drives. In the companies also, they have shared drives. Right? So is there any mechanism, Kishore, Hamid, and whoever is working, they can answer me. And so is there any mechanism, as soon as I loaded data into this, let's assume that I have loaded something called slash employee data. I have loaded employee data. Is there any mechanism I'll get employee data replicated in 3 places or 4 places, at least 2 places?
No.
Kishore,
No, Veera.
right? The very first limitation is we do not have replication, automatic replication. The second one is these machines will hold specific type of data. Each machine will go with a specific type of data. It holds only employee, it will not hold student. It holds employee, it will not hold student. Why? Why it will not hold? Because this is meant for the employee, that's not meant for the student. The student has this different data. Right? Different mission. The student is a different type of data, and it has a different system to store the data. Correct? So because of it is storing a specific amount of the data in the single machine, if this machine goes down, I don't have a backup. If this goes down, I do not have a backup. Or when I started processing the data, it goes down, I lost my job. My job in the sense, it will the whatever the submitted the query, the data processing, that will be failed. That will be failed, right? So the data will be stored in a single machine. It's a sequential process. It has to process in this machine only. Correct? These are the limitations are leading to again time and cost. These are the limitations are leading and taking more time because it does not have a parallel process. It does not have a data localization, does not have automatic replication, and because of these things, when I'm processing the data using the distributed file system, it's taking so much of time to process it. Understand, guys? So this is how the traditional approach, traditional distributed file system works. That's why we need a special kind of a distributed file system, which is Hadoop distributed file system. Okay, how the Hadoop distributed file system works, we will see tomorrow, and will I'll show you how it will overcome the problems of your distributed file system under an existing system. Clear? Any doubts, guys? Okay, so that's it for today. If you guys have any doubt,